What is the law of reflection? It's not a trick question. The law of reflection, if it comes up here, is the angle of incidence equals the angle of reflection. Just as a quick reminder, any ray that comes from an object will obey the law of reflection if it hits a mirror, so we can draw a normal to the mirror, and then the reflected ray disappears off at an angle that is equal to the angle of incidence. If we follow those reflected rays back, we can find out where our image appears to be, and it's behind the mirror, it's the same size, it's the same distance away from the mirror, and for a plane mirror like this, again, it is upright. So I've just talked about 4 really important characteristics of images. The location of the image, so its distance, its size. Sometimes, well, for a plane mirror, it is the same size, or it could be, for some mirrors, enlarged or diminished, which means smaller. The orientation of the image, so is it upright or is it upside down, so is it inverted? And the type of image. Now, a virtual image is what we see in a plane mirror. The rays appear to come from behind the mirror. You can also get images which are real, so that you can actually, the rays pass through a point, and we could actually project the image onto a screen, and that happens for concave mirrors, which we'll see soon. Here's just a quick example for a convex mirror. The rays from the object hit the mirror, we draw the normal, and the reflected rays disappear off at all those angles there. Then we can look at where those rays appear to come from, and there's our image. It's behind the mirror, so it's virtual. It's upright, and its distance is smaller than the object distance, and it's actually a smaller image than the actual object itself. For a concave mirror, just an example here, we'll go through these in more detail later. The rays hit the mirror, they all reflect according to the law of reflection. Where do those rays appear to come from? They appear to come from behind the mirror at a further distance away. Turns out that it's larger. It's still a virtual image. The rays only appear to come from that point. And what other information do we want? It's upright. One last example. Again, a concave mirror, law of reflection. Those rays reflect. They all pass through a point, and then they go on to any observer that's looking in the distance. And our image here is real. You can actually put a screen at the point where those rays converge and have an image of the object that you're looking at. In this case, it's inverted. The image is inverted, it's upside down. We're going to go through these in a little bit more detail for concave and convex mirrors in the next video.